We got a fun little problem today. We're going to be helping David figure out what centripetal acceleration he should spin his sling with so that he can hit Goliath in the head. And right now, Goliath is 102 meters away, standing at 3 meters tall, and he's on top of a 10 meter podium. So, knowing all of this, let's start the equate. Let's start the. Oh yeah, additional things to know. Um, he had the sling. He's holding it such that it has a radius of 30 centimeters, and at its lowest point, the bottom of the sling is 40 centimeters above the ground. And if he's going to shoot the sling at a 30-degree angle above the horizontal. So knowing all this, we have to help him find the centripetal acceleration at which he needs to spin his sling at. So what are we looking for specifically? Well, the easiest way to do this is to use the equation Vf squared equals Vi squared plus 2a delta y. That will give us the y component of velocity needed in order to reach the elevation at which he's at. And that's going to put the peak of the arc of the projectile right at Goliath's head, and that's what we want. So we just have to plug everything in, and we can use a bit of algebra. And after that, we're gonna get the equation for VIY to be the square root of 2g delta y over sine 30. Now we've got that, but we don't know delta y. And if this were a bit simpler, if he was shooting it at a 0-degree angle with the horizontal, delta y would we would know delta y. We would know the original displacement above the ground, but we don't, because it's 30 degrees. The tangent of that sling is 30. It's 30 degrees above the horizontal. So we're going to have to do a bit of work to find out delta y's like initial displacement. So we've got the sling here, 30 centimeters at its lowest point, 40 centimeters above the ground. Now it's moved such that the line connecting here and here has a 30-degree angle with the horizontal. So we can use math to know that this complementary angle here has to be 60, because this angle formed here is 30, and so they have to add up to 90. So this is 60, and since these two are equal, this also has to be 60. And since we have 120, the only angle that could be here is 60, and that gives us an equilateral triangle. So we have 30, 30, and that means this length here is 30. So now that we have this length here, we can calculate the length here, x, which is the extra displacement above 40 centimeters. And we're going to find x equals 0.3 sine 30, and that's going to give us 15 centimeters for x. So the total y displacement from the ground to where Goliath's head is, we're going to get 12.45 meters for that. And now that we have that, we can plug that in back to our original equation to find the y component of velocity. And we're going to get 2g times 12.45 square root of that over sine 30. That's going to get us 31.245 as the y component for our velocity. And now that we have that, we can use more trigonometry to find vt, the total tangential velocity of the ball. And that's pretty simple. We just plug in 0.31, no, not 0.31, 31.242 over sine 30, and that's going to give us 62.484 meters per second. And now that we have tangential velocity, we can pretty easily find centripetal acceleration, because that's just v squared over r. And we're going to have v squared, we already know what that is, 62.484. And then we just divide it by r, which, as you remember, is 0.3 meters, 30 centimeters. And when we plug that in, we're going to get centripetal acceleration to be 1,314.167 meters per second squared. So if David spins his sling with that acceleration, it will knock Goliath right in the head, and he wins the war.